Hi everybody, I'm Taisha, an application engineer at Keysight Technologies. In this video, we will talk about SPICE model quality assurance and how Keysight MQA software could help tackle the model QA and benchmark work that may be seemingly easy at the beginning, but rather challenging and time-consuming down the road. Device SPICE models are fundamental to our circuit design. The earlier we find the defects, the sooner and less expensive it will be to fix them in our design life cycle. Keysight's MQA frees model engineers from tedious measurement loading, complicated foundry library parsing, and interacting with simulators, all the way to report generation. MQA takes care of and automates the entire QA flow and comes with abundant built-in QA routines for every standard SPICE models, as well as check functions that can auto-detect and flag violations. Yet it's fully customizable and easy to use. With proper configuration, it makes sure a fully validated model library from day one all the way to our release date. Let's walk through the following 4 steps to see how MQA runs for model QA and report generation. First step, let's launch MQA and check links to external simulators. MQA runs on both Windows and Linux. Its main window opens and you may see previous saved QA results on the project tree panel. To review results, highlight a project node and click the green light arrow icon here to expand the folder. Graphs will be shown in the browser window. In order to run model simulation, we need to firstly make sure MQA has linked to simulators successfully. To check a simulator's availability, go to Menu, Utilities, check SPICE. In this example, we are going to use MQA's built-in SPICE 3 simulator, which is compatible with HSPICE formatted models. Click OK. It should say Successful shortly. Now that the simulator is working, let's go ahead to create a Model QA project. Go to Menu, Model, Lab Explorer to bring Lab Explorer window up. In there, we could create and manage all the projects. It further breaks down to 3 steps to finish a QA project. Step 1, load and configure the model file. Use the green plus icon to pick up a model file. The one we're going to use is the built-in example, a MOS BSIM4 model, located in MQA's example directory. The content of the model file is displayed once loaded. To start work on a model, check the checkbox in front of it, and its information will be presented in the Model Info setting panel. Most properties should be fetched from the library correctly by the program. However, do examine them carefully. Next step, let's move the cursor to the top right. Click on the first icon to create a QA project. Verify the model's checkbox is selected and click Next to advance to next step, where we specify the project's name and path. MQA is going to create a project folder under the specified path. Make sure that each project has a unique name, and there are no spaces in names and path. In the middle part of the window, we have a field called Rule. It refers to QA routines that define the simulation setups, plots, and check functions. And further down, there is a ICF file, which controls devices' name listing. And it also defines how device targets are calculated, such as threshold voltage, VTH. They are both essential and important, and will be further explained in other videos. For now, let's go with the default ones according to the model type and level. Click the OK button at the bottom to finish the project creation. Lab Explorer window will automatically bring us to the project panel where we see QA rules. There are more than 100 built-in QA rules in multiple groups for BSIM4 models. I'm going to deselect all and just select a few rules to run, such as check ID set versus L, under model scalability, and check IDVG and check IDVD under Mathematic Robustness. Now, move the cursor to the top right corner to click the green play icon and click Run button to run the project with selected QA rules. Once it's done, close the log window and click the View Project Result icon to load the results into Project Panel, where we can view the graphs. Please be noted that the libExplorer window now ducks to the bottom. To generate a report document, simply go back to Highlight the project's root node, right-click, and pick Export Report. The Report Wizard window will display. Choose PDF as a format, then click OK. We shall see the PDF document exported shortly. Lastly, double-click the libExplorer tab at the bottom to undock it. Click the Save button to save all the settings. With the saved.ini file, we can restore everything in libExplorer window and continue to build more QA projects. That's it. Our journey of Model QA will continue next time. Please subscribe to our channels for more videos, and thanks for watching.